Okay, now we're going to go through some of the ambiguous cases. We have an ambiguous case when we have a side-side angle triangle. That's where we're given an angle, the side opposite that angle, and then one of the remaining two sides. Okay, so just a quick note, the ambiguous cases have to do with making sure your triangle has exactly 180 degrees. So keep that in mind. I'm going to be getting to that a little bit later in some of the other examples. Okay, so let's start out with a no triangle example. So we're going to let A equal 62 degrees, or I'm sorry, alpha equals 62 degrees, A equal 12, and B equal 20. Notice that I have A and alpha, so that's my angle, and my side opposite my angle, and then my remaining side B. I could have also called this C, doesn't matter which remaining side it is. Alright, so let's set this up using our law of sines. So since I want to solve for my remaining angle beta first, I'm going to set it up as sine of 62 degrees over 12 equals sine of beta over 20. Alright, now to solve for, let me just shift this a little bit. Now to solve for beta, I'm going to have to multiply both sides by 20. Okay, so I'm going to get 20 times sine of 62 degrees over 12 equals sine beta. Alright, and I'm going to plug this in my calculator and make sure that it's in degree mode. So I'm in radian, need to switch that to degree. So it's going to be 20 times sine of 62 divided by 12. Okay, and that gives me 1.47. And that equals sine of beta. Okay, now you might be running ahead of the game. If you try to enter this into your calculator, what you're going to get is that if you try to take sine inverse of 1.47, you're going to get undefined. Remember that the inputs for sine inverse, so if sine inverse equals x equals y, then we can only input numbers between -1 and 1, and 1.47 is too big. So that means when we try to take the sine inverse of this number, we're going to get that that's undefined. Alright, so that means that we have a case of no triangle. So if I were to draw this triangle out, or try to, then what I would get is I would get a triangle with 62 degrees. The side opposite would be 12. Okay, and then this side would be 20. And see how this side's never going to be long enough to connect to my base without obstructing this angle. Okay, so that is when we would write no triangle. Okay, so be sure to make sure that before you take the inverse that this number is less than 1. Okay, now we're going to move on to two triangles. Okay, so we're going to let beta equal 55 degrees, A equal 8.5, and let B equal 7.2. Now notice I have my angle, my side opposite that angle, and then one of the remaining sides. Alright, so let's get started. Let's go ahead and let's try to solve for alpha. So we're going to have sine of 55 degrees over 7.5 equals sine of alpha over 8.5. Okay, so then to get sine alpha by itself, we're going to multiply both sides by 8.5. It's going to give us 8.5 sine of 55 degrees over 7.5 is going to equal sine alpha. Alright, let's put that into our calculator. So that's 8.5 sine of 55 degrees divided by 7.5. That's going to give us 0.928 about. Okay, so that means that sine of alpha equals 0.928. Alright, now this is fine because 0.928 is less than 1. Alright, now let's make a little note. Remember when we were talking about reference angles in 7.3? That sine of alpha equals 0.928 in both quadrant 1 and in quadrant 2. Now this is where the two triangles come in, is that I could have two angles that satisfy this. Okay, so let's take a look at sine inverse of 0.928. Let's see what that gives me. So sine inverse of 0.928. That gives me an angle of 68 point, let's round that up to 13. Okay. So it gives me 68.13 degrees. Now because this is an acute positive angle, that's also going to be equal to my theta r. Okay, so that's going to be equal to my theta r. Let's also call this my alpha 1, okay, because it's going to be one of the possible angles I can use. Alright, so then since we're in quadrant 2, we know that theta r equals 180 minus theta, the theta we want to find. Alright, so that's going to be 68.13 equals 180 minus theta. Alright, so if we solve for theta, we're going to get that theta equals, actually let me write that up here. We're going to get that theta equals 180 equals 111.87 degrees. And let's go ahead and let's rename this our alpha 2. Right, so our two possible angles that can satisfy this equation up here. Alright, so now what we need to do is that we need to check and see if either of these angles violate the fact that a triangle has to have 180 degrees. Alright, so we need to make sure that 55 degrees, that's our original degree that we were given, plus 68.13 degrees. Alright, so if you enter that into your calculator, you're going to get that that indeed is less than 180 degrees. Alright, so that means that we have enough degrees to play with for the third angle. So that's less than 180 degrees, so we are good. Now let's check the other angle that we had. So that's 55 degrees plus 111.87 degrees. And that's going to give me 166.87 degrees. This is also less than 180, so that gives me enough angles to play with for the third angle as well. Alright, so now we're going to use a fresh sheet of paper. And we're going to cut this up into two sides. Alright, so we're going to write down the information we were given initially on both sides. Alright, and then we have A equals 8.5, and we have that B equals 7.2. Alright, so that's one side. Going to write the exact same thing on the other side. A equals 8.5, and B equals 7.2. Okay, now for this side, I'm going to write one of my alphas. So I'm going to write alpha 1 equals 68.13 degrees. And then on this side, I'm going to write the other alpha that I found. So that's alpha 2, which equals 111.87 degrees. Alright, now I'm going to solve for the remaining side. So I still need to solve for C, and I still need to solve for gamma. Alright, so let's go ahead and solve for gamma first. That's pretty easy. That's going to be 180 degrees minus 55 degrees minus 68.13 degrees, and that's going to give us, that's 180 minus 55 minus 68.13. That's going to give us 56.87 degrees. Okay, now to solve for that other C, we're just going to go ahead and use the law of sines that we know. So let's go ahead and use B. So we have 7.2. over sine of 55 degrees equals C over sine of 56.87 degrees. Okay. To get C by itself, we multiply both sides by the sine of 56.87. So then that's going to give us 7.2 times sine of 56.87 divided by sine of 55 equals C. And that's going to equal, let's go ahead and plug that into our calculator. 7.2 times sine of 56.87 divided by sine of 55. So that's going to give us about 7.7. Right, so this C is about 7.7. Right, so that would be one triangle that I could possibly have. Now let's go over to this side. Again, we're going to solve for gamma. That's going to be our easiest bet. So we're going to have 180 degrees minus 55 degrees minus 111.87 degrees. Okay, so it's going to give us minus 11.87. That's going to give us 13.13 degrees. Right, so that's going to give us our gamma. Right, now to solve for C, we're going to do the same thing over here that we did. So we're going to have 7.2 over sine of 55 degrees equals C over sine of, and now for this side, notice that our gammas are different. So we're going to do 13.13 degrees. Okay, multiply both sides by sine of 13.13. It's 7.2 times sine 13.13 divided by sine of 55, and that is going to give us, so that's 7.2 times sine of 13.13 divided by sine of 55. Alright, looks like I made a little error on my calculator. There we go. Okay, and that's going to give us 1.99. Let's go ahead and call that 2. Okay, so now I have C equals 2. Alright, so these answers up here are my two possible triangles. Now let me give you a visual representation of what that looks like. Okay, so what I have here is that I have the information given to us in the problem. Okay, so as you can see, I have a red straw that has length 8.5 inches. I measured it out. And then I have this green straw, and this has measurement of 7.13 inches. Right? So notice that I can lay the straw down here on this line. This line is going to give me an angle of 55 degrees. Okay. And if I do that, then this side here, 7.3, this side here, 8.5, and if I take out my tape measure, then I get the bottom here is about 7 point something. Okay, and as we had in the problem, that is exactly what we would expect. We would want about 7.1, and that's about what that is if we round off for error. Okay, now notice that I can also swing this straw in. It's going to stop about right here. And see how it's still touching the line? Okay, but now I have different angles here. This angle is significantly smaller, and this angle down here is significantly bigger. The length of the straw is the same, so let's go ahead and measure this and see what we get. Alright, so now we get, at that inside measure here, it's going to be about let's say about 2.2, so we can round it off to human error again. We're working with straws, not straight lines. Okay, so notice that I can either swing this in, or swing it out, and I get two different kinds of triangles. And notice that the angles here change. So this angle here is acute, and then when I swing it in, right, I'm going to get an obtuse angle. Okay, so let's move on to another example. Let's move on to our one triangle example. Okay, so one triangle. So we have A equals 17, B equals 22, and beta equals 32. Again, I have my angle beta, a side opposite, and then some other side. Alright, so let's go ahead and solve this like we did all the others. So we're going to have sine of 32 over 22 equals sine alpha over 17. Okay, I'll multiply both sides by 17 to get sine of alpha by itself. So then if we plug that into our calculator, we are going to get that that equals, let's see, plug into our calculator, 17 sine of 32 divided by 22. That's going to give us 0.41 equals sine alpha. Okay, now since this is less than 1, we're good to go. We're going to have a triangle. And remember again that this is going to equal, sine alpha is going to equal 0.41 in quadrant 1 and in quadrant 2. Alright, so let's go ahead and start plugging this in. We have sine inverse of 0.41. Alright, so that's going to give me 0.41. That's going to give me 24.2 degrees. Alright, so that's going to be my theta r. Now if I check this in quadrant 2, right, remember theta r equals 180 minus theta, so we have 24.2 equals 180 minus theta. Okay, so then if we compute that, we are going to get that theta, or I'm going to call it our alpha 2, so this is our alpha 1, is going to equal 155.8 degrees. Okay, so we have two possibilities. We either have alpha 2 equals this, or we can have our alpha 1, which equals 24.2. Now remember, the angles in our circle have to add up to 180. Okay, so let's test these out. We have 24.2 plus 32. Okay, and that is going to give us 56.2 degrees, which is less than 180 degrees, so that gives us enough to play with for a third angle, so that one's good. Now notice when I do 155.8 degrees plus 32 degrees, that is going to equal 187.8 degrees, and I have none left over to work with my triangle. So that one's bad. So we're only going to have this answer here. This answer gets crossed out. Alright, and then we go about solving our triangle as we usually would. Okay, so now we're going to do solve for gamma, and that's going to give us about 123.8 degrees. Alright, now that we have our gamma, we can solve for c. Okay, so that's going to be 22 over sine of 32 equals c over sine of 123.8. Right, solve for c as we usually would, and we're going to get that c should equal 34.5. Okay, then we're all done. We have all of our sides. We have A, B, C. We have all of our angles, beta, alpha, and gamma for one triangle. Alright, next we're going to be moving on to bearing and explaining what that is.